Okay, in this problem, we're asked to compute V0 using superposition, and we're going to utilize the problem-solving strategy entitled Applying Superposition. And if you look at that strategy, it says if we have a circuit with multiple sources, each source can be applied independently with the remaining sources turned off. See, so we have two sources. We have a voltage source and a current source. So what we'll do first is we're going to go in and analyze the circuit with this source active and this source inactive. So we're going to turn this source to 0. So when we do that, we take that current source and replace it by an open circuit. So here's our resulting circuit that we have. We've taken the current source and we've replaced it with an open, or we turned it down to 0 current, which is characterized as a open circuit. So we need to now calculate the contribution to the voltage V0 from the 12-volt source, and we can do that using voltage division. Okay, so using voltage division, we have V0 prime is 12. We want the voltage across the 2K, so we have the 2K in the numerator, 3K plus 4K plus 2K, and that gets us 8/3 of a volt. So the voltage source acting alone, it provides a V0 prime voltage of 8/3. Now what we'll do is we're going to go in now and deactivate the voltage source, turn on the current source. When we turn this voltage source to 0, that's going to be like a short circuit. So our resulting circuit then is here, and here we can see the voltage source was over here. We turned it down to 0, so that's characteristic of a short circuit. So to start off, first what we'll do is we're going to apply current division, and we're going to calculate this current. I'll call I1 double prime. Okay, so using current division, we have I1 double prime, 2 milliamps, and we want the current through this part of the circuit, so we're going to put the 3K in the top. Then we'll have 3K plus 6K. Well, the 6K is a series combination of this 2K and 4K in series. That gives me an I1 double prime of 2/3 of a milliamp. Now, let's calculate the voltage. I'm going to call it V1 double prime, and I'm going to get V1 double prime. I'm going to use Ohm's law in the passive sign convention. Okay, so V1 double prime, we have 2/3 of a milliamp times 2K, which is 4/3 of a volt. Now, if I look at my circuit, I can see that V1 double prime has the opposite polarity of V1 double prime, so V0 double prime is minus V1 double prime, which is minus 4/3 of a volt. So the polarity for V1 double prime, I1 double prime also flows through this resistor. Using the passive sign convention, that gives me the polarity for V1 double prime. So now by superposition, if I have both sources active, V0 would be V0 prime plus V0 double prime, so we'd have 8/3 minus 4/3, or 4/3 of a volt.